Okay, here is the process of data mining and knowledge discovery. So many people consider data mining and knowledge discovery the same. If you consider data mining exactly the same meaning as ADD, all this process is also data mining. Otherwise, here is the actual focus of KDD, and the main part is data mining, which is, as we mentioned in the last session, is about extracting knowledge from data. So we collect data from many different sources. It can come from databases, from historical information, from whatever we define as goals of our application. So we have to select and integrate those data. And we have to also keep in mind that this is an iterative process. So when we extract useful information as knowledge from the data that we have, so those knowledge usually get some feedback from for example, customers, and then we update that, keep the ones that are more relevant, and update, for example, the database. So this is an iterative process. And then we learned that in data mining, we always start with the data cleaning and data preparation, which is the most important part. And after you do the data preprocessing, which includes the cleaning, transformations, reduction, and everything, then you have to extract the patterns. And not all these patterns are always interesting. So there might be millions of patterns in data, but some of them are interesting. So we have also another step of pattern evaluation and presentation, which help us to extract knowledge, which are the part of the data that we would like to present to users. So that is the knowledge is what you actually present to users. So what kind of data? We have several forms of data. We have, for example, relational data, transactional data. We have examples of each of these categories of data. We see them today. And time series, sequence, graph, social networks data, and so on. And so for relational data and structured data, what is a structured data? Could be, yeah. So we can store the structured data in tables, for example, what you, for example, do in your database course if you took it. So you store your data in tables and rows. In tables, which includes rows and columns. And so that the example here, for example, shows a table about the temperature, humidity, and whether, for example, you can decide whether you want to go out and play, let's say, for example, tennis or not. And there are some information. And what we do in data mining is, for example, if you want to predict that at certain day with specific features of whether you are going to, for example, play or not. So that is one example of data mining question. So, for example, if it's sunny and not windy, are you going to play or not? How about if it is not sunny and it's windy? So these are just a few examples. And transactional data, here is an example of transaction database from a grocery store. So you see, for example, you have a transaction ID and the items that you bought. And these kind of data are very helpful for pattern discovery. For example, when you want to find out what items customers frequently buy together, which is what most of e-commerce websites also does. And for example, what kind of pattern combinations customers like to buy together. Or we can later see, for example, what sequence of patterns can represent to us, can show us. So, for example, sometimes if you buy A and B, then you will buy C. Or if you buy A, then B, then you may also buy C. So these are all types of pattern discovery that we will discuss in this class. And textual data, this is another topic that I would like to cover if we have time. So we try to go over textual data and see, for example, if we may like roll data from social networks or like using APIs and then get some textual information. This is a very common task in data mining because there are lots of textual data there. So in the e-commerce websites, the social networks, and it's very important to analyze those kind of data in order to understand what your customers like, what users in social media are thinking about a specific topic. And to know, like, for example, in political context, text mining can help like different parties to understand what people are thinking about, what are the expectations. And so this is also very important to know what kind of sentiment or emotions they have. And the problem is that the textual data is highly unstructured. So it's not like the data that we saw in the weather table that you can like easily say, okay, these are the attributes and these are the rows. So this is kind of unstructured data, and we will learn how to deal with it. So these are just examples of what can be discovered from a text database. Like, for example, text classification models. For instance, if you want to like do stance classification to see whether users agreed or disagreed to like a specific topic. Let's say you post the content and there are lots of users responding to that, and you want to see, for example, whether people agreed or disagreed. So that's, for example, examples of stance classification, but it's not only stance, like any kind of like text classification. Or keyword and content association, summaries, topics. Sometimes you have like a lot of textual data. You want to like, let's say you have a lot of textual data about COVID-19 and you want to like do topic modeling. So you want to just get like, what are the main topics discussed? What are the main themes? So you see, for example, after like doing topic modeling, you can figure out, for example, based on your analysis, you see, okay, there are like topics, main topics are about vaccine, mask, or for example, quarantine, and these kind of things. And here is an example of XML data, spatial data, which contain information about location and geographic information. And any information actually about the location and shape of like the relationship among geographic features. So like, for example, maps, satellites. And another type of data is time series data. And can you give me an example of time series data?
Strong prices.
Yeah. And what else?
I guess like scores from like a sports game.
Sorry?
The score from a sports game, kind of oscillating changes.
Yeah, so can you give me a common feature of time series data based on like these examples? So what kind of data we can say is a time series data? Anything changes with time?
Yeah.
Yep.
Yeah, so we can go about the weather, because here the weather is going to have, like it's going to keep changing and we have to predict what's going to be the next forecast. So for that we can use time series.
Yeah, exactly. So it's kind of like periodic and you have like some changes with the time. And usually you want to like analyze what happens, like, for example, periodically, or you want to, for example, say regular intervals or repeating patterns from time to time. What about like your daily water consumption? Is it your daily water consumption is time series data? Yes. Okay. And we also have graph data. graph data are also very popular these days, especially because of fully interconnected network and world that we're living in, with like social networks or even in the financial world. So you can see several types of graph data here. And what is a graph?
Visual representation of data.
And what is the difference of graph to table? Because table can also be visual representation of data.
There's relation between entities.
In graph?
They're connected by two by two. They have they're related.
Yeah. Yeah, kind of. Yep.
We normally like.
You're very close.
Normally it's like a one-to-one relationship in a table, but here it could be like a one-to-many relationship. So one node could be connected to a lot of different nodes, but in a table, I guess this one makes the
So we cannot have one-to-many relationship in table. Like, for example, if a student take several courses, enroll in several courses. So, for example, if you have a student table, and you have a student IDs, which is a key because they are unique, and then some information might repeat here for each student, so cause one-to-many relationship. So for tables like relational databases, we often avoid to have many-to-many relationship, but one-to-many, it's okay. So we can have that. But with the graph, you're right. So one node can be connected to like several other nodes. And yep.
Depends on like the graph to be ordered or not ordered. When you just like start from a node, you only have like as I said, like it can't be like a couple. A certain path to follow it before you get to a certain information. So it's not like I think you have access to everything all at once. Like for example, there is no like index in terms of accessing, and you have to follow a certain path to get to like a certain node.
Yeah. Okay. So the only thing you have to know about graph for now, or graph data, is that graph data contain nodes and edges. Edges are what linking those nodes together. So for example, you can see several examples here. Like for example, the very simple one on the top left is the molecular representation of aspirin. And you can see, for example, biological networks on the top right. You can see social networks, financial networks. So, for example, I think a very sensible example here is social networks. So you can maybe understand it better. So the way you are connected to all your friends in a social network can be represented by graph. So, for example, what in a social network, what could be nodes and what could be the edges?
The nodes would be people, and the edges would be like a relationship between people.
Yeah. So what connect those nodes is a friendship or the relationship between those users. And here you can see a graph data set. And like, for example, yeah.
Actually, do you want to finish your statement and then I'll ask my questions?
No, it's fine.
So you're talking about the difference between a graph and a table. Could you then just clarify specifically what the difference is?
Yeah, so with the table you mentioned we cannot have table you mentioned is one-to-one, not one-to-many. But I mentioned we can actually have one-to-many relationships because in a relational databases, for example, when you have a, let's say, customer table, and that a customer may buy many products. So what is the relationship between customer and product now? Like in this case, it wasn't a good example because it's a many-to-many relationship, because also each product can be bought by many customers. But let's say a student enrollment in a course could be one-to-many if, for example, we say that for like if a student can only enroll in one course, but like in each course, many students can enroll. So that is like a one-to-many relationship. But when you're talking about like graph data, it's another like another type of data. Like it's we're talking about nodes, not tables anymore. And the connection is through the edges. Like for example, you have when you have a social network data, it's much easier to represent that data with the graphs rather than showing it with tables. So we do, because there really a lot of like information. First of all, lots of repetitive information, and second of all, there really, if you want to store it like in a in let's say table, not that it is not possible, but in a large scale, it is quite like not possible. But like if you're working on a very small example, you may like be able to, like if you're working on a very small subset of like a social network data, and you want like have like specific task of database, you may be able to do that. But in general, we store like social network data in graphs because it's much easier like to do graph mining on them rather than putting them like in tables, which is not scalable. And yeah, I hope I answered your question.
So graph is a good way to visualize it, and it's usually used when you have a small amount of data, so you can see all the different nodes. Versus with the table, it's usually better to store the data because that way you can have trillions of rows. Like one can be converted to the other, but tables.
Yeah, it's you don't need to like find a way like to like see a clear distinction. When you see like more examples as we go further in the class and as you like work, you get more experience with data, you can feel like what type of story is more suitable for what type of data. But when we are like for social network, it's quite like, I think it's quite clear because most of the like the social network representation is about connecting users to each other, right? And representing that, showing like a graph is much more clear than a table. Like if you want to like show your friendships, do you think you can show it, a graph can show it better or a table? Like your, for example, Facebook friends. Yeah, for example, let's say you want to like find out like the link prediction, for example, like friendship prediction. So it's easier to understand when you present it with graphs rather than like other types. So for example, here are some examples of graph mining tasks. For example, if you want to find communities in social networks, find the most influential people in communities. These are especially very popular in the politics context when they want to find like local communities in social network, or for example, finding influential people it can be also very useful in e-commerce and like for like all businesses. Node classification for anomaly detection, or for example for fake news detection. So what are the basic data mining tasks? So we can do data mining. We said that data mining is all about extracting knowledge from the data, finding patterns, right? So you can like have predictive tasks or descriptive. So if you are going, let's say, to discover patterns based on current or previous data, based on, for example, users' history, to make some kind of prediction. So for example, you see in a, like you have an e-commerce website, you see in customer table, what was his purchase history, and based on his or her purchase history, you may be able to predict what he or she may be interested. Or for example, in the movie context, Netflix can predict what you will watch next or what you will like based on historical data it has from you, like what you were browsing, what you were liking in the past, what you were watching most. So here in the predictive task, we can have a classification or regression. I'm going to cover them like very briefly today, but throughout the class, we will cover classification more in depth. We will go over like different algorithms like Bayesian classification, decision tree learning. And for regression, we don't cover that in this class because I assume that these topics are going to be covered also in machine learning. So we try to have as less overlap as we can. And another task could be descriptive. So data mining is not always about predicting something. It's also can be also about discovering patterns. So when we talked about finding, for example, association rules, mining, or finding, for example, frequently bought item together, the recommender systems use that a lot. For example, in Amazon, you see if you buy, for example, let's say this and this, you may buy that.
Is it that predictive as well? Because it's predicting based on the other users.
If it's if you are finding like patterns, like for example, when user buy this and this, is usually also buying the other. So it's kind of pattern discovery. So because you're finding a patterns, like for example, every time is milk and, for example, bread, there is also butter. And so this is kind of finding, it's more descriptive than, because it's already there. So it's kind of a descriptive task. And some data mining tasks can be both predictive or descriptive. And okay, so here, for example, for predictive tasks, here is a form of supervised learning, and you can see that the examples here are, let's say, our training examples, and they are labeled with target output. So we have a table. I'm not sure if you can see this, or is it too small? Okay, so we have information about patients. We saw this example in previous session. For example, for predicting whether, like what disease customer has, a patient has. Does she have, for example, allergy, cold? And do you remember what type of a classification model we could use for this? To see whether a patient has a cold or allergy? Decision tree, exactly. Because we said, okay, so we saw in decision tree that we had something like this. So for example, sore throat, yes or not, yes or no. And if it's, for example, yes, and then it may have like some other conditions. If it has some other conditions, then it can again go like yes or no. It's not only for this table, but also, for example, for the weather data example that we saw earlier. So you see, for example, if the weather is sunny, under any like circumstances, I will go to play. So in that case, yes is always play, right? So it doesn't go to further branches. But if it's like, okay, it's sunny, but it shows that not always when it's sunny, you go to play. If it's sunny and windy, you don't go. If it's sunny and not windy, you go. So after checking for the sunny condition, you also check whether it's windy or not. So if it is, the weather is sunny and the weather is windy, so if both is yes, and then you don't play. If it is sunny and it is not windy, then you play. And then it could be also other branches here. The same is here. So if a patient, so my eye doesn't see well here. So for example, if a patient has sore throat, and can we say with sore throat alone what patient has? What could be the diagnosis? With sore throat alone? No, we cannot. Because sometimes with sore throat, yes, diagnosis could be a sore throat, could be, for example, cold, and we have to see also other features. So it is kind of a difficult task for humans, especially if this table is getting bigger with more number of columns and rows. So this kind of task is what we do in data mining. And so, for example, do you remember the decision tree for this?
I guess the first level was swollen glands, right? It was if the patient had fever. And that's what it.
Yeah, exactly. So it's not important if it's exactly the same, but I wanted to know that you get the concept. So you see, for example, okay, let's say it may not be correct because I don't really see well here. For example, let's say if there is fever and congestion, then the conclusion is that it's a strep throat. If fever is no and congestion is yes, then it might be, for example, cold. If it is, for example, sore throat, fever, for example, no headaches, something else. So depending on these attributes, you can predict whether a patient has a cold, allergy, or other disease. So the goal is like to learn a model from labeled data to make predictions on the future data. So another, back to your question about like graph data and relational data. So data is not always as clean as like we can like easily put it like in tables and put it in like a kind of structured way. There might be like a noisy data or like lots of like missing data. So that those are also the things that we cover, especially with regards to noisy data. Or for example, handling missing values. We will cover them next session when we learn about data preparation. So tasks of predictive, types of predictive tasks and supervised learning. So we talk about classification, regression, and structured prediction. What we cover in this class, in this data mining class, not I mean today's session, but in general, is the first one. So in classification, the target variable is discrete. So you are predicting a discrete. And its values are considered as labels. So the example that we saw in the table in the previous slide, the diagnosis could be, for example, strep throat, allergy, or cold, right? So here you see these are our target variables. So the target variable is discrete. It's not continuous. So for example, you may want to like classify an image to see if it's cat or dog. So this is also discrete. What about the weather data? Is it discrete or continuous?
It's continuous.
Continuous. So classification models, we have different classification models like decision trees. We can have set of rules, Bayesian, support vector, neural networks, and we will have a session on neural networks as well. And for different types of model, different types of learning algorithms are designed. Here was the example I was talking about. So for example, if the weather is sunny, based on the information on this table, if the weather is sunny and humidity is high, are you going to play tennis? It's easy. No, you don't go. So if it's rainy, what do you do? If it's rainy, are you going to play or not? Depends on the wind, yeah. And if overcast, then yes, you go play tennis. So that was for classification. We are not going into like in depth for today. I'm just providing an introduction to different topics that I'm going to cover in the rest of the class. Regression. So one difference with classification here is that our target variable is a number. So it's continuous. It's not a discrete value anymore. So for example, house price, if you want to like predict daily water consumption, exam score, any like numerical value. So what is the objective here is to learn a model from the label training data to model the relationship between input and target variables. So this is another difference. So what was the goal in classification? We was learning a model, again, based on labeled training data, but what was the difference? Yeah. Yeah, in classification, you're going to predict classes or discrete values, for example, whether, sorry, where was I? Here. Yeah, but in regression, we are predicting a numerical value. And learn model is used to predict a numeric value for a new example or the relationship between input and target variable. So the target variable in the example here, so we have 3 columns, hours, preparation exam, and exam score. And based on these, for example, preparation hours, you want to find, for example, let's say the relationship between preparation hours and your exam score. So that what is the dependent variable here? Your target. So what you are going to predict, that is going to be your dependent variable. And independent variables are all those variables or attributes that are helping you for like that prediction. So in this case, for example, the preparation exams. But for example, if you are going to, let's say, predict, for example, a house price, you may have a big table with many features. What could be the features if you want to like predict a house price? Location, size, yep. Like the age of the house. So many like the rate of, for example, the school in that neighborhood, location, as your friend said. So there are many different features. These are all your independent variables, which are going to help you to predict the house price, which is a target or dependent variable. So we have different types of regression, linear, nonlinear. We can have simple or multiple regression. So the difference between linear and nonlinear only lies between the how is the relationship between those independent variables and your target variable. So if the relationship, if you can fit like a linear line, if a relationship is linear, then it's a linear regression, otherwise it's nonlinear. And the difference between simple and multiple regression is that in simple regression, we can only have one independent variable, but like the example that we had in the slide here, but multiple regression was like the example that I mentioned now in the class. So simple linear regression example. So you can see here age and systolic blood pressure among 33 adult women. And here's an example of fitting a linear model to our data to predict, for example, what could be, for example, SBP in a specific like age. So like that red line is your linear regression line. And multiple linear regression example, you can see it here. So for example, your exam score is based on the hours and preparation exams. So you have like two variables here considered to predict it. And you fit it to a line of 67.67 plus 5.56 multiplied by hours minus. So this is like the y equal to, for example, x plus something, right? So that is a linear model. So we have also structured prediction, which means that the outputs are structured objects. For example, we can have sequence-to-sequence problems when both inputs and outputs are a sequence. For example, in machine translation. So far, we talked about the predictive task in data mining, but sometimes we just want to have like a descriptive task. For like, for example, clustering, when you are grouping your data into different clusters and sections. Or for example, concept characterization, we'll talk about it later. Association analysis, like frequent item sets, association groups, and sequential pattern mining, like when you can mine data based on the sequence of patterns that you find in the data. And sometimes they are predictive or descriptive. So about the descriptive data, the training data don't have any output or target variable. So here we're not going to predict something. We're not going to predict, for example, whether you are playing or not. We are not predicting the stock, for example, price or house price. We are, for example, finding associations. We are finding patterns between like different features of the data. And can you tell me what kind of learning, supervised or unsupervised, is more suitable for this task?
Unsupervised.
Why?
What is more about these problems that usually require unsupervised?
So for unsupervised learning, what is the difference with supervised?
I actually don't know.
Anyone knows?
Like supervised is labeled, unsupervised is unlabeled. And here, I think because we're gonna extract hidden patterns, unlabeled data would be better.
Yeah, right. So, so for supervised learning, for example, classification, we have labeled training data, and we are going to predict something based on that labeled training data, right? But when we don't have that, then we normally use unsupervised learning, and as your friend said here, it's more suitable with unsupervised learning because we have input data without any output or target variables. So the goal, as I mentioned earlier, is to either extract hidden patterns or the relationships between data, or discover knowledge that characterize general properties of data. So this is all descriptive. We are not predicting or forecasting anything. We are just describing what are, for example, the relationships between different features of the data, or what kind of patterns we can find. So this is kind of, we are just describing the data. And typical descriptive tasks are clustering and association analysis, sequential pattern mining. Here's an example of clustering. So what is clustering? So the class label is unknown in the training data. And in clustering, we are going to group data to have different clusters. So how are we going to group them? So we want to, one main principle for clustering is that you want to minimize interclass similarity and maximize intra-class similarity. So for example, if you have, like this is your data, let's say I'm clustering them into these 3 clusters. How did I do that? Based on not my image here, but these points are our data points. So based on, let's say, assume that based on my analysis, I realized that data here in this circle are more similar to each other, and they are not similar to data in this cluster, and they are not similar to data to this cluster. So when I'm talking about intra-class similarity, I mean here. So the relationship between the data that are clustered in one group of data. But inter-class means between two different classes. So when I say maximizing the inter-class similarity, inter-class means between this and this, between this and this, or this and this. And what are the applications of clustering? For example, if you want to group your customers based on, for example, their shopping behavior, if some customers have similar, for example, shopping behavior, putting them together. So you see here, we have 3 groups or clusters of data. Each cluster, within each cluster, the data are very similar, so the similarity is maximized, while between these clusters, we are trying to minimizing their similarities. And concept characterization is summarizing of general properties of objects in a target group. For example, characterizing customers who spend more than a specific amount a year in, for example, some store and have excellent credits. And so what is the result? For example, we see that what features, what are the characteristics of this group of people? They are 40 to 50 years old. They are usually employed people. An example of association analysis is here. So, for example, you say age X and something, for example, from 20 to 29, and income between, for example, 20 to 29K. So if this is the case, they usually, for example, you see that they often buy, for example, PC. And so it's kind of finding some rules of association in your data, right? Is it clear? And it's widely used for market basket or transactional data. For example, what products are often purchased together.
What's the support and confidence in the previous example?
Yeah, we always have to evaluate our, for example, when we define a rule, let's say when we define a rule, we want to see how good this rule is. So this is kind of like to measure the goodness of a rule. So for example, we can say with 60% confidence that this rule works. And mining sequential patterns, finding frequently occurring patterns in the sequence database. For example, you see within the, for example, past 3 months, buying computer, then buy USB drive, then buying digital camera. So you see this sequence, and the applications is in sale campaign analysis, or for example, weblog analysis, etc. Or it can be like for predictive or descriptive, like time series data. We also see some examples of time series analysis here. So your friends provided some examples of time series data, like for example, weather data was one example, and stock market here is another example. So these are the data that frequently you can expect that they change with time, and you can find some period like changes from time to time in the data. So in time series analysis, you can, for example, search for periodic patterns or recurring patterns in your time series database. For example, daily traffic pattern. So there might be like a specific pattern at a specific times. The traffic is heavier, while at some points in the day, the traffic, for example, early morning, less traffic, afternoon, more traffic. So that is also a kind of data that changes with time. So what will be covered in the lectures in this class are, we are going to cover classification. For classification, I will cover decision trees and Bayesian classification. We will cover clustering, for example, k-means. And we will cover association analysis, sequential pattern mining, and in the last sessions, if time permits, we will cover text mining, sentiment, emotion, stance, topic modeling. So now, what is the question? What is the difference between classification and regression?
Discrete data versus continuous. For the classification, when we use discrete, and in regression we use continuous.
Yeah, right. And
Finding out that answer, I'd say classification works well with categorical data, and regression works well with numerical.
Exactly. And what is the difference between classification and clustering?
Classification is normally when you're working with data that already has the labels, versus clustering, you don't have the labels, and you're basically trying to find them.
So far, what I would like you to learn in today's class was to first learning how to, you have to be able to know what is data mining, and you should be able to differentiate it from machine learning and some applications of data mining. You have to know some applications of data mining, some examples of different types of data. For example, what is graph data, what is text data, different tasks of data mining, could be predictive, descriptive, or both. For example, what are the predictive ones? What are the descriptive ones? For example, for the predictive ones, we talked about classification. For descriptive ones, for example, we talked about clustering, association rule mining, and the differences between these, what types of data they are working with, for example, discrete or numerical, and in what situation you are going to use which one. For example, to answer a specific question, this is actually very important later when you are analyzing the data. So you want to know, for example, you have a question and you want to know what to use. So for example, if your question is predicting something that is like a discrete value, then you know that you're going to use classification. Is it like a numerical value? It's regression. If you're going to, if you don't have any target variable and you have unlabeled data, you just want to find groups of similar, people, let's say, with similar behavior, what will you use? Clustering. And so this is just to know what to use in specific situations. And finally, the last topic in today's session is about the major issues in data mining, which are efficiency, effectiveness, user interaction, privacy, fairness, bias, and interpretability. So these are the main issues we have to consider when we design a data mining system or work on a data mining task. So for example, when we do the data mining research, we mainly design the algorithms, right? And when we are using those data mining algorithms, it's always important to know how well they are working. This is, for example, can be evaluated based on their efficiency and their effectiveness. And so this is about like the performance of the algorithms of data mining. But there are also other issues. So efficiency is about developing fast and scalable data timing. So efficiency is all about the speed. So for example, you have a data mining algorithm and you want to see how fast it is. So it's developing fast and scalable data mining. And effectiveness is all about the accuracy. So how to develop model from your data to make accurate predictions. The third issue under the effectiveness is how to present data mining result in an effective way. So we talked about the data mining in an iterative process, and how do we design for the user interface in a way that allow the interaction between the user and our data mining system to be more effective. So one way is like one way is through a good visualization technique. And there are, of course, problems with the privacy, fairness, and bias. So, for example, your algorithm is fair if errors are distributed similarly across different groups of data. So if you evaluate your algorithm only on if it works only good on your data, but not another context or another data, that's not fair. And interpretability, which is also very important. For example, in recommender systems, when you're recommending a product to a customer, it's also important to rationalize your choice. So they may want to know that why you decided, for example, they have to buy this item. Why, for example, this movie, they might be interested in this movie. So sometimes you see that in Netflix, it says you may like, for example, this movie because you liked that and that. So that's about explainability. And that's it for today. And so for next session, I'd like you to take a look at the Lab 1 tutorial that I put in the e-class. So install Jupyter Notebook. Try just to get started with it so we cover data processing.